If you're familiar with the Rail Safety Improvement Act of 2008, a lot of people playing with their phones and texting when they should have been driving trains, things like that. And the history of positive train control, which has really been around for 50 years or so, but that act back in 2008 drove PTC to be a real regulatory requirement. So we've been working very closely with the freight rail organizations throughout the United States and others in adopting up-to-date advanced communication technology and integration capability. You might imagine that there's a whole lot of tracks across just North America alone, right? Let alone the entire world, as it would be. A lot of tracks there, a lot of archaic technology on those tracks, a lot of areas where wireless communications can be extremely cumbersome down those paths, things like that. So if you look at the PTC requirements or regulations, we're focusing primarily on the areas where you're going to carry really bad stuff. You're carrying a lot of weight and a lot of tonnage, so if you did slip a track, it would be a very bad problem. If you're carrying toxic, bad chemicals and things like that. Focusing on those main areas. And that's about 60% of the tracks that are out there, largely by the freight rails, of course. But if you understand those tracks that may be owned by a Norfolk Southern, a CSX, right, are shared by passenger rail systems, especially, of course, in the Northeast Corridor up there, places like that where it's very congested. Chicago, a gigantic multiplex of tracks going in and out. So we have to cover a lot of different areas with this technology, but we're focusing on the ones where you're going to afford the most safety to these scenarios. And then if there's a track going out in the middle of nowhere, that's kind of our last case scenario at this point.
Yeah, and you can imagine a scenario, and it's probably there right now, right, where you have cameras on crossing lights, and engineers can see ahead, miles ahead, right?
Mm-hmm.
That must be installed.
It's very difficult to see miles ahead on a train.
They would be broadcasting somehow, right?
Yeah, back to the engineer.
Yeah, and you've got a bank up here,
actually,
or wherever
the
it is in the
engineer
cab.
is monitoring only the instruments on his train. He does not look at any video being broadcast back to him currently.
Yeah, for probably safety reasons.
Exactly. His eyes are on the track.
Yeah, and there, of course, are dispatch centers that also would integrate with local law enforcement and safety and traffic divisions that would be able to harness the majority of those visual inspection devices, if you will, at a crossroads, rail crossing or something like that, an intersection, area that needs highly secure. Those are going to be provided by those local municipalities. And so, obviously, since the beginning of the railroads around here, there's been quite a lot of knowledge sharing and asset sharing between government entities and the transportation organizations overall, so that they can cross-benefit from those technologies.
As an engineering team, what do you guys learn from the kinds of technologies that you deploy in that application and put it in others? Or conversely, what are you learning elsewhere that you're deploying into locomotive communication applications?
Well, actually, I think it started from the military side of things. We were building things for the military. We knew, and then getting into the rail side, has all the same kind of requirements. So it's easy to take the requirements out of the military side and relate them to the train standard. If you read the train standard, the S5702 specs for environmental and EMI and all that, it's almost verbatim MIL 810 and 461. It refers back to that. So there's a lot of back and forth. The rail industry, relies on military specifications a lot for meeting their requirements for their electronic packages that are placed on trains.
Mm-hmm. And one illustration of how technology is driven by government and defense, things like that, right? There's a lot of advancement going on, in part driven by Cisco Systems, one of our largest integration partners, of course, in something called radio-aware routing. With radio-aware routing, this is not just these mobile vehicles talking back to some fixed infrastructure, because as we talked about with trains going through areas where it's really hard to get infrastructure, even wireless infrastructure, deployed with 100% coverage, you can imagine the same problem if you're going to deploy a military asset into a previously unknown location. right? So they're working to create more technologies where not only we're communicating to fixed infrastructure, but we're ad hoc communicating between each mobile node back and forth, with satellite communications as well, but a more rapid convergence of communication paths, right? Sort of like taking the traditional routing that you would see in building-to-building communications, and when a line goes down, it automatically reroutes to another, right? Integrating wireless technologies in the same type of asset, being driven by the defense world and the U.S. government, and then being able to apply that to the same factor when you have a locomotive, a consist, they call a train a consist, all the cars and locomotives on that. Usually you might have a 2.5 mile train, but you've actually got 3 places where you have electricity. You've got 3 different nodes that are actually driving and providing that distributed power source, right? So being able to communicate back and forth to those. Sometimes you're not going to get necessarily a line of sight from one locomotive to the other. And if you're going through a yard, being able to have adaptive technologies to communicate ad hoc between different locomotives, between wayside stations, and bounce that technology, wherever I can get contact is how I'm going to get contact, is a really good innovation being driven by that.
Where do you guys, if you were masters of the universe, where would you take that technology?
I'm not. My wife's been lying to me for years. So sad.
Oh, well. If you guys were masters, all right, you are masters of the universe. Where would you take that technology and deploy it into areas that it's in applications that it isn't today? I mean, it could be automobiles, it could be somewhere else, but we're sort of the next frontier for that technology.
Well, it's sort of going there. So, all the mobile devices that we have out there, really going, with our handheld communicator applications. You see that there's applications out there now where originally when we started with these really cool devices where we could take a picture and put it on a website, now we can take a picture and immediately share it with everybody that's in our proximity based on the GPS utilization within it, right? Taking that same technology now, it's extending into vehicles where it's not just a vehicle connecting to a mobile device that you have, it's a vehicle that actually has mobile communications, maybe cellular communications built into it. And those vehicles being able to communicate in real time with the road system, right? When we talk about GPS providing traffic information and things like that, that's very helpful. But what if the vehicle itself could provide statistics, just like we're trying to do with the trains, about the tracks and its environment? Those vehicles could provide information back to your traffic department locally, so that they could say, these vehicles are having a really strange vibration issue consistently at this one section. Okay, let's deploy a truck out there. Wow, that's a giant pothole. Or in Florida's case, that's a huge sinkhole. We should build another road. Right, that type of real-time communications, being able to identify issues fast, I think is really where we're going with it. And it's not just about people, it's about assets talking to assets, right? Devices talking to devices. Everything is a connected node at this point.
Yeah.
The automobile industry, car to car.
Right.
As you're driving down the road, it's the communication. I'm near you're near me. We all need to stay a certain distance apart. You alarm the drivers, and it's all coming.
Prevent that guy who almost
Absolutely.
sideswiped us today.
Yeah.
That's never going to stop.
I wanted to go back to something you mentioned. You were talking about the system level, and you were talking about power management, right? The guys who are building silicon are obviously working to optimize power management there. What are your tricks? What are you seeing when you take that stuff and you're putting together a system? How are you optimizing power?
Power management techniques using different operating scenarios of how the device works, learning the users, how they operate the device, how do they need it to operate, what are they doing with the device, do they need it to work 100% of the time, or is 50% of the time okay, cycle power in and out, change functionality, don't give them complete 100% functionality all the time, just give them a portion of it. So it's understanding the system requirements, really the customer requirements, how are they using it. Of course they want the world, and then you scale back and you say, okay, but I can give you this and it'll last this long. And they're like, well, I didn't think if I just had that little piece of the pie that I can still do this. And then when I need the whole thing, I can, on the fly, change the power management cycle to it and now get it to operate in this. One thing we're finding, the silicon's getting smaller and smaller, so our devices dry, but everybody still wants it to last forever. So the batteries, we still got to have batteries. And one of the things that we've been joking here for years with some of the guys I've worked with, it always comes down to power.
Yeah,
it always comes down to power. Everything we have, our cell phones, and thank God for cell phone technology, because that's really what's driving the power industry. your iPads and your iPods and things like that. Is how do we make these things last as long as they do? Large screens on them today, and look how long your iPad lasts.
I know. That's remarkable to me.
Yeah.
Just remarkable.
And so we're constantly monitoring, and then it's for us in the law enforcement world. They can't afford to go buy $100 battery packs. When it's time to replace a battery, they want convenience too. So it's still, we have to look to the commercial market. What's available? They can go down to the local drugstore, local Walmart, or wherever, and buy that new battery that's on the market that's driving a camera or being used in some other electronic piece. How can we make sure we take advantage of that and integrating that into our new device, and not making them go buy that $50 battery? And so that's important to those customers. Military, it's not quite as important, but I think they're the single largest user of AA lithium batteries.
Mm-hmm.
I mean, that battery is by far, I'm waiting for the next one.
Yeah. And you see where, sometimes we talk about what commercial applications to drive other technology, right? We talk about the transportation industry. We've had significant power issues and challenges that we've had to face working with transportation, especially the locomotive industry, right? Train industry, you sit here and you look at different problems, and people think of really cool energy distributed energy generation technologies, and look at hybrid cars out there and using regenerative braking and stuff like that, and think that's really cool and innovative. Well, if you didn't realize, right, it was locomotives that really drove the development of that technology. Right.
Over regenerative braking.
Mm-hmm. Yeah, those those diesel engines, they've got gas, but you slam in those big brakes, that's a lot of power. We need to save some of that and store it back up, right? So you get a lot of that technology advancement. We learn a lot by working with the locomotive industry just for that piece.